We now welcome on stage our first competitor, Mr. Krzesimir from the European School, who shows up with a project of recurrent neural networks with a layer of long-term memory applied to capture the structure and generate a typical weather year for the city of Luxembourg. Good luck.
Moin, I'm Krzesimir Hyżyk from the European School. This year, for the Jonk Fuerscher contest, I have developed a project that utilizes recurrent neural networks with a long, short-term memory layer for analyzing temperature data in the Luxembourg City. Recurrent neural networks have an ability to capture the structure of sequential data. I have utilized that property of recurrent neural networks to analyze the temperature data for Luxembourg City and create an artificially generated typical meteorological year for the Luxembourg City. Temperature data is recorded as a long time series. That means each data point consists of a timestamp and a temperature recorded. This data is also sequential. That means each value depends on the previous ones. I have sourced my data for the publication, monthly weather reviews based on hourly data, Luxembourg Findel Airport, for the years 2015-2020. The data from the Findel Airport consists of over 50,000 data points, each of them representing a temperature recorded in the span of 6 years. However, recurrent neural networks aren't able to make sense of raw unpreprocessed data. To overcome this, I have split the original dataset into two small datasets, each of them corresponding to one of the neural networks. In my project, I have utilized two recurrent neural networks, which are a type of neural network that is loops, for better capturing of persistent information and patterns in data. In my case, a single long short-term memory layer is iterated about 20 times. It consists of the following gates: the forget gate, the memory gate, the input gate, and the output gate. The network has also a second layer called the fully connected layer. It translates the output of the LSTM layer into the desired format, which in my case transforms a vector of size 150 to a vector of size 1. I have coded the project in C and trained the recurrent neural networks on the GPU. Both of the neural networks have been trained individually on their own datasets. For the training itself, I have used the backpropagation training method. The two separate neural networks generate two output vectors. To achieve a continuous data sequence, I had to merge them in a specific way. Compared to the original dataset, the generated results have an outstanding accuracy of above 95%. After normalizing the data, a typical meteorological year for the Luxembourg City can be obtained. A typical meteorological year is, for example, used to calculate the heating degree days and cooling degree days. These are statistical indexes commonly used by engineers to estimate the energy usage for heating and cooling. As shown on the heating degree days graph, there is an estimate of 2,819 heating hours in a year. This value is very similar to the number published by Static for the year 2019, which was 2,814. Comparison between the typical meteorological year published by Eurostat based on the years 2007-2016 and my results based on the years 2015-2020 shows that Luxembourg City is getting warmer even on such a short time scale. This can be seen as a demonstration of a global warming effect. I have successfully applied a recurrent neural network with a long short-term memory layer to model sequential temperature data. I have combined 6 years of generated temperature data to obtain a typical meteorological year. Based on the typical meteorological year comparison, the average temperature between the years 2015-2020 has been higher than the years 2007-2016, which can be seen as a demonstration of a global warming effect. Thank you very much for listening, and I'm happy to answer your questions.